I've been pretty excited because I got notification from FedEx that I had a package that needed to be signed for, and I knew I only had one item that I was expecting in the mail, or I didn't realize the shipper had sent it out signature required, and I wasn't home yesterday, so I got one of those little stickers on the door. So I had to wait until today, fill out the thing, put it back on the door, and wait until today, and sure enough, it showed up. This came from Texas. Well, I should say the last stop was Texas before it came to me. But where it's really from, transistor inverter. This is a hint right there as to what it is. But as far as where it's from, right down here, made in Taiwan. This is my new Tico variable frequency drive. They call it a variable speed AC drive on here. This is a model JNEV-203-H1FN4S. This is says the weight is 6 kilograms and doesn't really say much else on there. The specs and everything are not on here, but I did all that when I was going through the whole decision-making process. I should have a video up that I'll put a link to right here. Probably going to call the video something along the lines of like VFDs for dummies, or VFD buying guide. I mean, I'm just going to basically put up a video with the knowledge that I ended up finding out about these things based on some of the websites, manufacturers' websites, and then also a lot of really good information on some forums out there. A lot of differing opinions on different things. But anyways, that video will cover more the why and how I came to decide on this particular model, as opposed to say like the Tico, I think FM50 or one of those, or another manufacturer. So anyways, without further ado, let's take a look at what's in the box. Yeah, so I'm down here last night. I barely get started and the battery dies on the camera. So anyways, back down here, and you can finish unpacking the thing. But since I had to go upstairs because the battery died, I had a chance to actually go through the owner's manual. And I haven't looked at the little DVD yet, or whatever this is on this disc. But really some interesting information in there. So let's finish unpacking this puppy. It's bigger than I thought it would be. I think part of that though is because this is in the NEMA 4 enclosure, which also drives the price up quite a bit on this thing, if you buy it new. Well, this is new, but this is some kind of weird situation where this guy only had 3 of them and was able to sell them at a greatly reduced cost. So that's where the gambling part comes in. There's no warranty card or anything in here to fill out and send to the company to ensure that I'll be covered under warranty, so I don't know if I'm going to have any warranty on this thing. This is clearly a brand new unit though. And it's got a serial number on the side there, so I guess worst case scenario is if I have an issue and I can't get any satisfaction from the seller, I could always try and contact the company. This is a 3 horsepower, 2.2 kilowatt. This is a single phase 200 to 240 volt input, 21 amp. Output 3 phase, 0 to 240 volt, 10.5 amps. So this should be plenty big enough to run my 2 horsepower Doer motor over there on the mill. Got a massive aluminum heatsink on the back. Don't see a cooling fan, so it looks like everything's cooled by this heatsink. But what's nice is because it's in this NEMA 4 enclosure, I basically could just find a place to hang it on the wall, run my wires in and out, and I don't have to buy like an electrical enclosure or box to house it in. The only other items in the box are these strain reliefs for the cables. Looks like, I don't see any knockouts on the top, so it looks like all the cabling is supposed to come in and out of the bottom here. These plastic plugs, I don't know, maybe there's nuts on the inside holding those on. Well, anyways, let's take a peek under the cover. I think before I do that though, I'm going to read what this little thing here says. This is a note telling me that for IP65 200 volt 2 to 3 horsepower filter models, additional items will be found inside the box, including 1 PC of EMC conformed waterproof ferrite core. So this black donut looking plastic thing here actually is a ferrite core. EMC, electromotive something. But basically they're showing the cable running from here to the motor. They're showing this wrapped around the cable. Yeah, I don't know what they're talking about here. Please also note that length of the motor cable cannot exceed 5 meters under EMC regulation. EMC, I'm betting that has something to do with the electrical noise being generated. The ferrite core around the cable must do something to eliminate electrical noise. I'm thinking maybe when this is running, it would create a lot of electrical interference with nearby devices. That's just a guess. Well, that ain't gonna fit around the cable that goes to the motor anyways, so I was like, well, I guess I could take that cable off. But, and we got these nice strain relief. These are almost like weatherproof or watertight cable connections. They got rubber bushings in there. This is a really nice enclosure. This isn't your run-of-the-mill. I guess that NEMA 4 rating, I guess that's why it's so expensive. Let's take a look under the hood, shall we? This screw right here appears to be captive. In other words, it's made to unscrew and then stay behind with the cover so it doesn't get lost. Wow, it's a lot of screws. Hey, I didn't need to take all these screws out. That's why. I didn't realize this was 2 pieces. There's a rubber gasket in there even. There you dummy. Oh, there's a little cooling fan right there. Little itty bitty thing. This thing being all tight like this, I don't know what it's going to do other than just move the air around in there. Oh, and I see. This is a switch is mounted. Well, let me get this out of the way. Alright, let me back up for a second. Let me start by putting these screws back in. I've never seen that in the owner's manual. Looks like the one they show in the owner's manual. Okay, there is a section here. It shows a lot of the pictures in the owner's manual there. They deal with just the regular unit, not the unit that's in the NEMA 4 enclosure. So the way this comes apart is probably unique to the NEMA 4. Yeah, I should have realized that when these screws came out the way that they came out and stayed captive. Should have just unloosened these 4 and pulled up on it. Oh well. Alright, so I thought that this black part would stay behind here and that this would pull out around it, but this whole part right here comes out with the cover. I can't just unplug these plugs. Yeah, this seems like it might be different than when you order this without the NEMA 4 enclosure. We've got a few things going on here. One thing, you've got regular one, it's not an NEMA 4 enclosure. I think they've only got a potentiometer on the front for speed. They don't have this positive on-off switch. So I think they expect you to have a separate switch on the input. The manual tells you you're supposed to have a disconnect on the input. That goes without saying. It says you want to have fuses, a circuit breaker on the input. That goes without saying. But it also says you don't want to use the circuit breaker as a disconnect. In other words, you don't want to be going and shutting the circuit breaker on and off whenever you want to kill power to the whole system. But I think I can run from the circuit breaker right into this, because I think this will act as a disconnect. The other thing is, I get an extra knob here, 0 R F. So I believe that'll be the off position, reverse and forward. And I don't think that exists on the non-NEMA 4 units. That capability is there, but I think you actually have to add your own external switches. And this also has the ability to allow this to be added remotely. So what I could do, I should be able to take this 0RF switching and actually rewire my drum switch up there on the motor to mimic what this is doing. Cross that bridge when we come to it. Alright, bring the camera over and give you a look inside. Alright, so let's start by talking about what's on the back cover here. What's on the front cover. On the back of the front cover we've got a small cooling fan, which I mentioned, and judging by the position of that cooling fan, it doesn't look like it's blowing on any one particular item specifically. Just put my head in the way. So we got this little cooling fan here. We've got this little PC board, which corresponds with the little digital readout and the little soft touch membrane buttons on the front there. We've got this is the switch for the stop, forward, reverse, and you can tell by the size of these wires this is a logic switch. So this is just changing a logic state, and then the controller's doing the rest. The point is that this would be low voltage going through these wires, and somewhere there's going to be connections inside here where we would be able to actually run, if they're not already being used, we could actually run the wires, low voltage wires, up to my drum switch and mimic what this switch is doing. Only have it on the mill remotely. This little device right underneath here, this is the potentiometer for the speed control. Same thing with this. This little device, we could run a remote wire and actually mount another one of these right at the mill, making it easier to change speed right near the mill. This particular unit also has 6 or 8 presets that can be set up ahead of time for different speeds. So if I wanted to preset it so that whenever I use a fly cutter of a certain size or a facing cutter or something like that, just hit that preset and it automatically gets to that speed, I could do that. Set it up for different size cutters or things like that. So that's going to be a handy little option to have. And then of course this is the big main on-off switch that I talked about, and that corresponds to this shaft and this big switch right here. And this is clearly a positive on-off switch, and what I mean by that is when this is in the off position, no power is sent to the unit at all. It's just like unplugging it from the wall. How do I know that? Well, because here's the input for the whole system right here, L1, L2, and neutral. And then here's the output, comes right out and goes right to the board. There's no other connections to this switch between the board and the switch other than these 2 straps right here. So I'm glad to see that, because then I don't have to have another switch mounted on the wall. I can basically run my power from my breaker right into here, and then use this as my means of disconnecting power when I'm not using the system. Here are my connections that go out to my motor, T1, T2, and T3 for the 3 phases. And then there's these plus and minus, I forget what those are. That's in the owner's manual, it talks about that. All of those connections for doing like remotely mounted switching and speed control would be here on this terminal block. A lot of these are already have wire connections in them because they go to the potentiometer and the forward reverse switch on the front cover that I was just showing you. So each one of these little connections right here doesn't necessarily have to do that job either. You can actually go into the software when you're programming this and you can actually change what the different parameters do. There's a whole bunch of different parameters that can be set on this thing, and I'll have to get into that at some other point. Some of the parameters I have no idea what they mean. And reading online, a lot of the guys said you can just go with factory defaults on a lot of those unusual parameters. The more critical parameters would be like your max and minimum frequency, things like that. Which your max frequency is basically going to determine your max speed. If I set the max frequency to 60 Hertz, then basically the motor's never going to run any faster than it's designed for. If I want to, I can actually send higher than 60 Hertz to the motor, at which point I'll be over speeding the motor if I wanted it to run even faster. But then I run into a problem where I'm forcing the bearings and the drivetrain and everything else in the mill to do something it wasn't designed to originally. Might be able to handle it no problem, but I don't think I want to find out. I'd rather err on the side of caution as far as that goes. As far as the other devices in this thing, I mean, I've got a rudimentary knowledge here of some of these components, just enough to know what they are. And these two devices right here are large electrolytic capacitors. They're probably doing the job of some sort of filtering. And these capacitors have polarity, so these capacitors actually have to do with DC voltage, which is interesting. So they're probably using some sort of a DC control voltage. Not sure exactly how this works. I'm looking at this device right here, this flat pack right here. More than likely, because it's the only one that looks like that, that's probably the microprocessor. If any of you guys are real extreme geeks, part number on there looks like an IR2133J247P. So yeah, there's a relay down here. Tell you one of the things I am very glad to see is everything in here looks like it's properly soldered. There's not the kind of a train wreck that I heard about in some of the other processors. I meant to say some of the other, some of the really dirt cheap import VFDs that are popping up on eBay and other places. A lot of the people said, for the money that was well worth it, but a lot of those people never took a look under the hood of some of those drives, and there were some reports of some of them failing early within the first 8 to 10 months. Warranty almost being non-existent on a drive like that, because in many of those cases the people were buying them direct from Chinese shippers. Some of them disappear, or some of them just are non-responsive to email, that kind of thing. But the people who have taken those drives apart have often commented on how poorly things were put together. And this, from what I can see, looks like it's really well put together. I don't see, my quick cursory examination here, I don't notice any obvious bad solder connections or other things that scare the pants off of me. Looks to me like this little area right here, judging from all of these solder connections and the fact that there's a screw right through there, I'm thinking that might be the drive module right underneath there, and it's probably bolted directly to this massive heatsink on the whole backside. So now I think I get an idea of what's going on here with this fan. When the cover's in place, that fan is probably blowing air directly on the backside of this this area right here, because that's probably the drive, and there's a couple of holes in the board here that are just slots, so I guess air could get through there. But I think that's why the fan is sitting here. Well, alrighty, let's wire this puppy up and see what happens. Alright, so I was just looking at the wiring diagram, and it shows that they definitely want you using the grounds, which goes without saying. I wanted to use the grounds, but the weird thing is they don't say where the grounds are in here. But it does say that on the board that PE is a ground, so P, that's probably something earth, potential earth, I don't know. But if you look right here, there's a little tiny PE, and this is a ground symbol. And we get the screw right here, and this is attaching this run on the board at this point, and there's another one over here, both of these being attached through this screw to the heatsink. So they must be using the heatsink as the ground. Hey, you know what? Look at that. That must have cracked. That goes right here. Son of a gun. If I did that. I already broke it. Alright, gonna have to glue that. I'm gonna have to make darn sure I don't get any glue in the threads. Well, that little brass ferrule in there. Okay. Getting back to what I was talking about. So it looks like they're using this for the ground, and there is a threaded hole right here with nothing going into it. So I'm thinking this is where the grounds are going to have to terminate, because here on the switch they've just got the L1, L2, and L3 or neutral. Well, now that's interesting. I just noticed on this output side of the switch here, all you've got is L1 and L3 coming out of the switch. There's no connection from here to here. What the heck? So it looks like this threaded hole right here is going to be my ground termination point, which would have been nice if they had actually labeled it so that we knew for sure. But I don't see any other place on here where I can connect a ground wire, unless I took one of these screws out and put an eyelet underneath that, and I'm not crazy about that idea. But since this threads right into the standoff underneath it into the heatsink, this must be what they intended to use for a ground, because on the input connection to the switch right here there's only L1, L2, and L3. But I just noticed something else very unusual to me. On the output side of the switch they've only got straps going from L1 and L3, almost as if this is set up for 120 volt input. But this is not supposed, this is supposed to be a 220 volt input. It has to be. This is a 3 horsepower. They don't make a 3 horsepower unit that takes 120 volt input. So the question now becomes, where does L2 hook up? Is L2 supposed to hook up directly to here? Which, if that ends up being the case, now this switch no longer gives you a positive disconnect of power to this thing. I mean, technically it shouldn't be able to, power shouldn't be able to go anywhere. If the switch is off, L2 would just be floating. I don't like that. Alright, went upstairs, did a search online, and came up with the answer. First, let me explain to you again why this is so confusing. Down here there's a label, L1 with an L in parentheses, L2, L3 with an N in parentheses. So this would indicate that if you were wiring it 3-phase, if this model was for 3-phase input, you would have L1, L2, L3, pretty straightforward. But then it would indicate that if you were wiring it for 220 volt single phase input, you would think you would use L1 and L2, because L3 is typically only used for 3-phase, and then in parentheses it says N, which would mean neutral. So that makes you think, oh well, if you had a 120 volt input VFD, you would be using L1, and L3, which would also be neutral. So get back to, well, we're 220. So 220 single phase, you would think you would use L1 and L2 and not use the neutral at all. Problem is, on the output of the switch here, we can see there is nothing coming out of L2 to connect to this L2 connection here. So that begs the question, well, then is this jumper supposed to be moved from this location over to this location? No. When I went online and I searched for that specific problem, wiring the input on a Tico VFD, I found a couple of threads in some forums where people explained that when wiring one of these, you use L1 and L3 for your 220 volt input. So in other words, I'm going to take L1 and wire it to here, and I'm going to take L2, or my black wire, in other words red here, black wire, not going to go to here because it won't do anything if I did. I'm going to go to here. Neutral is not used, even though this says N in parentheses, and ground. So I don't need the neutral wire. So I'm just going to run, again, a red wire, black wire, ground. That's how you wire their input on this Tico. Now, you can't go by what I just said for your own unit. You've got to find that out on your own, because that might be different for your model. I could be wrong. Hell, I could do this and this thing might go up in smoke. But that's what I'm going with right now, in absence of any other information to go on.